Right now, somewhere in a brightly lit warehouse in Georgia, a two-legged robot is picking up plastic totes and stacking them on a conveyor belt. No one is guiding it. No one is standing behind a remote control. It just walks, lifts, and places over and over while fluorescent lights hum above rows of steel shelving. That might sound like a scene from a movie, but it's happening today in real facilities. And it's not a one-off experiment. There are entire companies being built around the idea that physical labor, the kind done with hands and feet and tired backs, can be handled by machines smart enough to learn on the job. If you work in logistics, manufacturing, or really any field where repetitive tasks eat up most of the day, this matters to you. Not because robots are going to steal every job overnight. That's the easy headline, and it's lazy. But because a handful of robotics automation companies are quietly building the foundation for an economy that will change which skills carry a premium and which ones don't. According to industry reports, over 4.5 million robots already operate in factories worldwide. Annual installations have topped 500,000 units for 4 years running. This is about potential trends, not financial advice. And what happens next depends a lot on who these companies are and what they're actually doing, not just what they promise on a glossy stage with dramatic lighting and a fog machine. So, let's break down 5 robotics companies that are shaping this shift right now, what makes each one different, and what it all means if you're trying to stay ahead. The first one you've probably seen in viral videos. Boston Dynamics has been around for decades, originally spinning out of MIT research labs with clunky prototypes that looked more like science experiments than products. But fast forward to early this year, and they unveiled something very different at CES. The all-electric Atlas, a humanoid robot built not for YouTube clips, but for actual industrial work. Here's what changed. Atlas is no longer a research curiosity. It's entering real production, with committed deployments to Hyundai, which owns Boston Dynamics, and to Google DeepMind for advanced cognition research. Picture this: a robot standing on a factory floor scattered with metal parts and the faint smell of machine oil, reaching for a heavy component and placing it precisely where a human worker used to stand for 8 hours a day. The electric redesign matters more than most people think. Hydraulic systems, the old approach, were loud, heavy, leak-prone, and expensive to maintain. Electric actuators mean quieter operation, significantly lower upkeep costs, and easier integration into existing factory layouts where human workers are still standing just a few feet away. And that last part is key. These aren't meant to replace entire production lines. They're designed to slot into the gaps, handling the dull, dirty, or dangerous tasks while humans supervise. But here's the tension worth naming. When a robot like Atlas handles a task that once required a trained worker, the company saves money. The worker, though, needs to find a new role. And retraining programs haven't kept pace with deployment timelines. That gap is where real disruption lives. The second company takes a different approach entirely. Figure AI burst onto the scene with massive backing from Microsoft, Nvidia, and even OpenAI, and in talks for funding that could value the company near $40 billion. Their latest humanoid, the Figure Aero 3, isn't just a body that moves. It runs on something called Helix, a vision-language-action model that lets the robot understand spoken commands, see its environment, and physically respond in one fluid loop. Imagine a robot in a well-lit living room, folding a wrinkled shirt it's never seen before, adjusting its grip based on the fabric's weight and texture. That's the kind of general-purpose intelligence Figure is chasing. They've also opened a dedicated research facility, the Helix Lab, designed to capture massive amounts of real-world human video data. Essentially, they're teaching the robot by watching how people actually move through kitchens, warehouses, offices, and living spaces, frame by frame, hour after hour. Their manufacturing arm, called BotQ, is preparing for mass production. Think of it like the way a river slowly carves a canyon. The data collection is the water, patient and constant. And over time it shapes the AI into something that can navigate genuinely unstructured environments. The thing most people miss about Figure is that they're not really a robot company. They're a data company that happens to build robots. If you're finding this useful, consider subscribing. No hype, just honest breakdowns of where technology is actually heading. Now, the third company is already past the pilot stage. Agility Robotics makes Digit, a bipedal robot that looks a bit like a headless human torso on backward-bending legs. It's an unusual design, but there's a reason for it. Digit was built specifically for environments designed for people, warehouses with stairs, ramps, narrow aisles, and uneven floors. By late last year, Digit had hit major operational milestones in a GXO logistics facility, moving over 100,000 totes without the kind of catastrophic failures that usually plague early robotics deployments. Picture a long warehouse corridor, the squeak of rubber on polished concrete, and a machine walking steadily between shelving units while workers nearby check clipboards. Agility's strategy is focused. They're not trying to build a robot that can do everything. They picked one environment, logistics, and went deep. Their RoboFab production facility is ramping from hundreds of units toward thousands. And this is where it gets interesting for anyone running a small business or managing a warehouse team. Agility offers something closer to a robotics as a service model, meaning you might not need to buy a $250,000 machine outright. You lease capability. The flip side. When repetitive tote moving gets automated, the warehouse workers who did that job need to move into supervisory, technical, or maintenance roles. And not every company invests in that transition. Some treat it as the workers' problem, not theirs. The fourth company on this list might surprise you because it doesn't build robots at all. Nvidia is the invisible engine behind almost every serious robotics effort on the planet. Their Isaac platform gives engineers a way to simulate entire robot behaviors in virtual environments before a single physical prototype is built. Imagine a glowing screen in a dim office, showing a digital twin of a warehouse where virtual robots test millions of movement patterns overnight. Earlier this year, Nvidia released new physical AI models specifically designed for next-generation robots. Their GR00T Foundation model is trained to help humanoid robots understand natural language and perform physical tasks. And their Cosmos platform generates synthetic training data, which means robot makers don't have to spend years collecting real-world footage to teach their machines. Here's the thing most people don't realize. The companies building the flashiest robots aren't necessarily the ones winning the automation economy. The company selling the shovels during a gold rush often profits the most. Nvidia sits at the center of a web that connects Boston Dynamics, Figure AI, and dozens of other robotics startups. If you want to understand where robotics is heading, watch where Nvidia points its tools. Still, there's a hard question here. When one company's infrastructure becomes essential to an entire industry, what happens to competition? What happens to smaller robotics startups that can't afford the compute? And what happens to the open source ethos that drove so much early robotics innovation? These aren't theoretical concerns. They shape which robotics automation companies survive and which ones get absorbed. The fifth company flips the script on pricing entirely. Unitree Robotics, based in China, made headlines with its G1 humanoid robot priced around $16,000. That's a fraction of what competitors charge. Imagine unboxing a robot the way you'd unbox a large appliance, pulling it from foam packaging on a garage workbench, the crisp smell of new electronics filling the room. Unitree's approach is similar to how affordable smartphones brought computing to billions of people. They're betting that the real automation economy won't be built by expensive machines in Fortune 500 warehouses. It'll be built by accessible robots in small factories, research labs, and eventually homes. Their G1 features ultra-wide-angle LiDAR for spatial awareness and modular upgrades that let users customize for different tasks. At CES this year, their robots demonstrated martial arts routines and dynamic agility that rivaled machines costing 10 times more. But affordability brings its own tension. Lower price points mean wider access, which accelerates adoption. That's genuinely exciting for small business owners looking to automate repetitive work without spending $250,000. It also means the competitive advantage of automation, which used to belong only to large corporations with deep pockets, starts to level out. If everyone has a robot, the edge shifts back to human creativity, judgment, and the ability to solve problems a machine hasn't been trained for. The playing field flattens, but the game changes. So here's the takeaway. And it's the part most people in this space get wrong. The automation economy isn't being built by one breakthrough robot or one genius company. It's being built by an ecosystem, each piece depending on the others the way roots, soil, and rain depend on each other to grow a forest. Boston Dynamics brings decades of mobility research. Figure AI brings the AI brain trained on real-world human data. Agility Robotics proves the business model works in real warehouses with real revenue. Nvidia provides the simulation and compute backbone that everyone else plugs into, and Unitree makes the whole thing affordable enough to reach small workshops and research labs that couldn't touch this technology 5 years ago. The real skill that becomes valuable in this world isn't knowing how to operate a specific robot or memorize its interface. It's knowing how to supervise automated systems, how to spot when something is going wrong before it breaks down, and how to define what good looks like when a machine is doing the work instead of a person. Think of it less like learning to drive and more like learning to be a flight instructor. You need to understand the machine well enough to trust it, and well enough to know when not to. Results here will always depend on your own effort, skills, and consistency. If public research databases and industry reports are your thing, the data on warehouse automation ROI is worth exploring on your own. What do you think is the biggest barrier to robotics going mainstream? Drop it in the comments. And if this gave you something to think about, subscribe for more honest breakdowns of where tech is actually heading.